Welcome back to my channel She Statistics. Today we are going to talk about the second portion of the Markoff theorem. So this portion states that if B cap is said to be an unbiased estimator of beta, that is if expectation of B cap is equal to beta. So to calculate this expectation, we take the expectation over here and substitute this value of beta. If you would recall from my previous video, this was the value. So S inverse X transpose, we open this bracket and this comes out to be expectation of Y into these two terms. So on substituting Y is equal to X beta plus E, then the error term, the expectation of the error term is taken, and hence we get S inverse S beta, which is equal to beta. This shows that beta cap is an unbiased estimator of beta. Now, since the matrix X and vector Y are known, and also since the inverse of a non-singular matrix is unique, from equation 3, if you would recall from the previous video, this is equation number 3. So from here, it can be seen that beta cap is unique. Next, to show that the variance of beta cap is the least, so we first obtain the variance of beta cap. So on substituting these values again over here, we get S inverse X transpose, that is the variance of the error term, into S inverse X transpose whole transpose. So on opening this bracket and solving, we get sigma square over here, then S inverse and X transpose X into S inverse. X transpose X will be S. So on solving this, we get sigma square S inverse. Now we consider any other linear unbiased estimate beta curl of beta which is different from beta cap, and let it be given by this value. Now since it is an unbiased estimator of beta, we take its expectation and this should come out to be we take the expectation, we substitute the value, and here we get beta, which is an identity in beta. Hence we have beta x, bx is equal to I. Now if this is beta x, and over here we have, if this is equal to S inverse X transpose plus C, then from this equation 4 we get, on substituting the values, that Cx is equal to 0. That is, beta curl is equal to S inverse X transpose plus Cy, where Cx is equal to 0. Also, the variance of beta curl will be the variance of this entire term. So on opening this bracket again, we get this term plus the variance of Y plus into this S inverse X transpose plus C whole transpose. So on opening this entire expression, we get sigma square S inverse X transpose plus S inverse plus sigma square C transpose plus sigma square S inverse X transpose C transpose plus sigma square C X S inverse. So over here, when we know from the above part that Cx is equal to 0. So on substituting those values, we find out this expression. So that means sigma square S inverse plus C whole transpose, CC transpose. So since the diagonal elements of this are the sum of squares of the elements of each row of the matrix C, hence they will always be greater than 0, and they will be 0 only when the elements of all the rows of matrix C are 0. That is, C is a null matrix. Therefore this variance is greater than the variance of beta cap. The equality sign will hold only when beta curl is equal to beta cap. So that's all from me for this portion. Thank you for watching. If you like the video, please share and subscribe. It will be continued in the next video.